So in this video, I'm going to be using the Lambert W function in order to solve 4 questions of increasing difficulty. So in order to use the Lambert function, we need to write the equation in the form u multiplied by e to the u, and that should equal some constant k. And the reason why we need to do this is because if we then take w of both sides, so w of u multiplied by e to the u, that's going to equal w of some constant k, we can then solve for x. So this will give me the solution that I want. So let's take a look at number 1. So number 1 is x multiplied by e to the power x, and that's equal to 3. Now that's already written in the form that I want. 3 is a constant, and so this works. All I need to do is I need to take w of both sides. So w of x multiplied by e to the x, and that's going to equal w of 3. Now we can't use a regular calculator to solve this. We can use something like Wolfram Alpha or any other special kind of calculator. So this will spit out the value for x. So x is going to equal 1,0499. Let's take a look at question 2. So x multiplied by e to the power 2x is equal to 7. Now, it's not written in the form that we need, because here we have x and here we have 2x. We need it to be the same. So what we can do is do a substitution. So I'm going to say let 2x equal u. That means x is going to equal u divided by 2. So I'm going to substitute that into my equation. So x is u over 2 multiplied by e to the power u, and that's equal to 7. Now I'm going to multiply both sides by 2. I'm going to have u multiplied by e to the u, and that's going to equal 14. Now that is written in the correct form. So I'll take w of both sides. So w of u multiplied by e to the u, that's going to equal w of 14. So this is going to give me u. So it's going to give me the solution for u. So u is going to equal w14. But remember, u is equal to 2x. So 2x is equal to w of 14. That means x is equal to w of 14 divided by 2. So x is equal to 0,982. Let's take a look at question number 3. As I said earlier, the questions are going to be going up in difficulty. So here we have x plus 1 multiplied by e to the x, and that's equal to 4. Now, in this case, I'm going to substitute u as x plus 1. So u is equal to x plus 1. That means x is equal to u minus 1. Now let's substitute. So I'm going to have u multiplied by e to the power u minus 1, and that's equal to 4. Now I can use exponent rules to break up the u minus 1. So u multiplied by e to the u multiplied by e to the power minus 1 is equal to 4. Now let's rearrange this slightly. So u multiplied by e to the u, and that's divided by e to the 1, that's equal to 4. Now I'm going to take the e to the 1 across. So u multiplied by e to the u is equal to 4 multiplied by e. Well, e to the 1 is e. Now I can take the w of both sides. So w of u multiplied by e to the u is equal to w of 4e. Now this is going to split out u is going to equal w of 4e. Now u was x plus 1. So x plus 1 is equal to w of 4e. That means x is equal to w of 4e minus 1. So x is equal to 0.79904. Now let's take a look at question number 4. And this is the last question, and it's going to represent the most difficult one. So here we have e to the x is equal to 3x. So I'm going to start off by dividing both sides by e to the x. So divide by e to the x and divide by e to the x. So I'm going to have 1 is equal to 3x divided by e to the x. Now I'm going to take the 3 and move it down here. So essentially I'm dividing both sides by 3. So 1 over 3, that's my constant now, is equal to x, so this, and I'm going to bring the denominator up to the numerator. So multiplied by e to the power minus x. Now I need to do substitution here. I'm going to say let u equal minus x. That means x is equal to minus u. So I'm going to have 1 over 3 is equal to minus u multiplied by e to the power u. Now let's switch them. So I'll take this entire thing, take it across there, and take this entire thing and move it across here. So I'm going to have u multiplied by e to the u is equal to minus 1 over 3. And this is good because now we've got it in the correct form. Now I'm going to take the w of both sides. So w of u multiplied by e to the u is going to equal w of minus 1 over 3. So this is going to split out u is going to equal w of minus 1 over 3. Now remember that we had u is minus x. So minus x is equal to w of minus 1 over 3. Now we have to be careful here because of this input value. Now this is the input. We are inputting minus 1 over 3. Because of that value being minus 1 over 3, we are going to have two possible solutions. So, and that's because this is the function, right? It's a weird looking function. That's how it looks. So essentially what we're doing is we are substituting minus 1 over 3. So minus 1 over 3 is equal to minus 0,33. So minus 0,33 is approximately, I'm going to say somewhere here, right? So let's say it's somewhere here, minus 0,33. This is the input value. And if I bring this up, it's going to cut the function in two places. It's going to cut the function here, so somewhere here, and it's going to cut the function somewhere here. So we expect to have two values. Now the red function, well, the red part of this graph is the upper limit, and the blue part is the lower limit. So on the calculator, on Wolfram Alpha or whatever calculator you're using, you do need to compute this. So when we are typing it, when we are writing it out, we're going to write it as follows. So for the lower limit, for the upper limit, W naught, we're going to have W naught of minus 1 over 3. So we've replaced W with W naught because now we have to specify, we're talking about the upper limit or the lower limit. And that's going to equal minus x. So when you compute this on the calculator, you're going to get minus 0,619 is equal to minus x. That means x is equal to 0,619. And now for the lower limit, W minus 1 of minus 1 over 3, that's going to equal minus x. This is going to give you minus 1,512, and that's going to equal minus x. That means x is equal to 1,512.